Okay, let's quickly talk about inequalities. Now, there's pretty much, when it comes to flipping inequalities, there's two rules, okay? When we're switching inequalities. Number one, if we switch sides, meaning if the variable switches sides. So, for example, if we have 3 is greater than t, right? Right, we want to bring t to the left and we want to bring 3 to the right. So if we do that, if we bring t to the left and 3 to the right, okay, we have to switch sides. So it's no longer 3 is greater than t, it's going to be t is less than 3. Now does that make sense? Is 3 is greater than t, that's the same thing as saying t is greater than 3, right? Okay, so again, if we switch sides, we switch inequalities. The second is if we divide by a negative number. For example, if we have negative 3t, so we have negative 3t greater than 18. We divide both sides by negative 3, but because we divide both sides by negative 3, the greater than sign becomes a less than sign. So it becomes t is less than 18 divided by negative 3 is negative 6. So keep this in mind. So when we do these problems, sometimes we might just use one of these two cases. Sometimes in the problems we might have both of them where we have to flip them. So you're gonna be flipping them twice in a problem sometimes, okay? Well, let's look down here. 30 is greater than negative 6p. Well, what we talked about, right, when we switch inequalities is if we switch sides or if we divide by negative. Well, you notice where the inequality, or not the equality, but the variable is? It's on the right. So we want to eventually switch it to the left. We're not going to do that now, but eventually we want to do that. And also we have a negative number here, so we're going to have to divide by negative. So we have these inequalities switching a couple of times, okay? Well, first things first. Alright, just imagine like as if this is just a regular equation. So let's solve for p. Okay, so we divide both sides by negative 6. Okay, so negative 6 divided by 6, we cancel that out. Alright, so let's bring down p on the right side. But because we divided by a negative 6, negative number, we have to switch the sign, right? Or the inequality. So it's that greater than, it's going to be less than, like that. Less than sign. Okay? And then 30 divided by negative 6, that's going to be negative 5. Again, we don't want to leave it like this, so again, we're going to flip it again. So we're going to bring p to the left, negative 5 to the right. So it's going to be p is greater than negative 5. Alright, let's go to the next one. Alright, we have something very similar as this previous problem. We have the variable on the right side, and we have a negative coefficient, or negative number here. So we're going to switch the sign twice again. Of course, whenever we have this kind of problem, what we could do, like if we have a fraction in front of the variable, we can use the cross multiplication. So we can say that 7 is 7 over 1. So what we can do is we can like cross multiply, right? So 7 times 8 is 56. You can say 56, alright, is greater than, alright. Now what's 1 times negative 1r? What's that going to be? Let's see, 1 times 1 is negative, and that's r, right? So we have 56 is greater than or equal to r. Not because we want to get rid of the negative. Remember, we divide by negative 1, not negative or by 56. We divide by negative 1 both sides to get rid of the negative. Alright, so when we divide that, we get an r, right? And the 56 divided by negative 1 is negative 56. Okay, now because we divided by negatives, we have to switch the sign. So it becomes less than. Okay? But because r is on the right side, we want to bring it to the left side. So it becomes r is greater than negative 56. So we switch the sign once, but because the variable's on the right, we switch it again, like so. Okay, let's go to a problem where we have multiple steps. So here we have 5x minus 21 is less than or equal to 2x. So what we want to do here is we want to isolate the x and the numbers, right? Okay, which means that we probably want to bring 5x to the right side. So we're going to subtract both sides by 5x because we do the opposite of what it is, right? 5x, so negative 5x. Subtract both sides by 5x, so we get, these cancel, we have a negative 21 left over, less than or equal to, what's 2x minus 5x? Well, that's positive 2, right? So they have opposite sign, just regular integer math, right? So we're going to subtract 5 from 2. 5 minus 2 is 3. Alright? But because 5 is greater than 2 and it has a negative, we're going to bring a negative down here, and it's the x. So we have negative 21 divided less than or equal to negative 3x. Now, let's divide both sides by negative 3. Alright, so the negative 3's cancel. Here we get 21. Oh, and what's negative 21 divided by negative 3? Alright, the negative becomes positive. 21 divided by 3, that's 7, right? So, because we divided, right, because we divided by negative numbers, we have to switch the sign from less than to greater than equal to x. But because the x is on the right side, right, we gotta bring it to the left, so that means the sign switches again. So instead of greater than, it becomes x less than or equal to 7.